morning, good afternoon, dear students. So we have here Harpreet Singh, Sahil Preet, and we have here Muskan and Sugandha Mishra. So welcome in today's class. So we have Vaishnavi Rana. Very good afternoon, dear. So let's begin with some questions. Find the sum of first 24 terms of AP. Find the question is find the sum of first 24 terms of AP is 8, 11, 14, so on. Find the sum of first 24 terms of the AP. And so here, in this algebra portion, for the first question is sum of first 24 terms. So we have studied that the sum of n terms is equal to n by 2 into twice of a plus n minus 1 into b, right? So in this case, a is 8, common difference d is equal to 3. So substituting the value, right? What is n? 24, sum of 24 terms, 24 by 2, 2a, that is 16, plus 23, d is 3, right? D is 3 here. So here is Abhinandan Swaraj, okay, 1020. So we have here that is 12. So here 12 into here 16 plus 3 is 9, right? So here, if it is answer is right, 12 into, right, it is 15. So here how 0 is not coming, 15 here, 1, carry 6 plus 7 plus 1, 8, 85. So here 12 5s are 16, 6, and so here answer that is 1, 0. The answer is 1 0, 1 0, 2 0. Sum of 24 term is right. So next question is, it is a question again from AP. If mth term, right, question is if the m times the mth term of an AP is n times the nth term, n times the nth term to that m plus nth term of the AP is 0. So here we have Tamanna Prani also, Sai Preet, okay, 1020, okay. So Samir is also there from 10C, right? Question is, if the mth term of the m times the mth term is equal to n times the nth term, prove that m plus nth term of the AP is 0. So here, what is the mth term? Mth term, m plus nth term is equal to a plus m plus n minus 1 into d, right? Into d, right? So this term we want to prove 0, okay? So here we have the m times the mth term, m times the mth term, that is a plus m minus 1 into d is equal to n times the nth term, a plus n minus 1 into d, right? So here what we will do, we will multiply, that is ma plus, that is m square d minus of md is equal to ma plus n square minus n square d common the minus of nd, right? So here we can just rearrange, that is ma minus na is equal to, here we have n square d minus m square d, and here is equal to md, it is plus of md minus of nd, right? So here we can take d common, right? So here a common, m minus n common, and a is common here, right? A is common, and this side also we can take minus sign common in order to make mn. So m here, that is m minus n d, right? And it is already d common, m minus n into d, right? So d is again common here. So here it is m square n square. This is what? M square n square. So we can take one common mn, right? Minus here, that is m square plus n square is equal to m plus n, right? So here what we can do, we can take, that is minus of m minus n into, right, m minus n into m plus n plus 1 into d, right? So here this mn and mn get cancelled, right? And here when we take, this is the negative 1, here plus is, this is separate one, right? So here what we have, this is minus of mn. So when we take here, this will become minus here, minus when we open the bracket. So here m plus n minus 1 into d. So here we have, this implies that a plus m plus n minus 1 into d is equal to 0, right? So here in this way we can prove that an a plus m plus n minus 1 into d, this is nothing, this is a plus m plus nth term, that is equal to 0, right? So in this way we can prove, right? So let's take few more questions. based on question is find the 11th term from the end. Question is find the 11th term 11th term from the end of the AP. From the end of the AP. AP is 10, 7, 4. Last term is minus of 62. Minus of 62. So we have discussed so many ways how to find the AP, right? So here we can want to find the 11th term from the last. So we know the formula that the last, that is nth term from the last, is equal to last term plus n minus 1 into d, minus d is negative, right? So here last term, that is minus of 62 plus 10 minus 1, that is 11 minus 1 is 10 into d. Here the common difference is minus of 3, so minus plus here, right? So we have 62 plus 30, so answer here, right? So 11th term from the last is equal to, that is minus of 32. Right? So Abhinandan, very right. It is minus 32. Next question. Next question is, how many 3-digit numbers are divisible by 7? How many 3-digit numbers are divisible by 7? Divisible by 7. Okay. So 3-digit numbers starts from 100 to 999, right? So here Sugandha Mishra also, Sailpreet, right answer is minus 32. So here next is, how many 3-digit number are divisible by 7? So 3-digit number which are divisible by 7 starts from your 105, 112, right? So on, and the last number which is divisible by 7 is 994. Okay, so these all are 3-digit number which are in the table of 7, or which are divisible by 7, leaving remainder 0. So here, to find how many numbers, we can apply here the concept of AP, that is an is equal to a plus n minus 1 into b, right? So here we are interested with n. So 1 is 994 is equal to 105 plus n minus 1 into d. d here is 7, right? So we have here 105 plus 7n minus 7. Okay, so here when we subtract here 98 plus here is 7n 994, right? So this implies that 7n is equal to 994 minus 98, and n is equal to, that is 14 minus 8, 6, right? So here 8, 18 minus 9, again 9, 896, and here is 7. So 7 ones are 7, 7 twos are 14, 7 eights are. So value of n, therefore the number 128, right? So Sahil also, that is the number is 128. Sahil also very right, and Sugandha Mishra also very right. So next question, that is find the sum of find the sum of find the sum of, that is 25 plus 28 plus 31 plus up to 100, right? Find the sum of these numbers, right? So here Abhinandan also very right, it is 128, n is 128. So here A is 25, B is 3, common difference is 3. So here first we have to find n. So an, that is 100, 100 is equal to a plus n minus 1 into d is 3. So here we have 25 plus 3n minus 3, right? So here this implies that 3n is equal to, so we have a 22, so 100 minus 22, right? This is 100 minus 22, so that is 78. N is equal to 3 2s are 6, 3 6s are 18. So value of n is 26. Therefore, the sum of n terms Sn, here sum of 26 terms is equal to 26 divided by 2 into a plus l, right? So here it is 13, a 25, and l last term is 100, right? So here we have 13 into 125, right? So when we multiply 125 by 13, right? 15, 6 1 7, 3 ones are 3, 125 here, 5, 12, 6, 1. So what is the answer? 1625. 1625. So Sahil Preet also will read 1625 is the answer. Okay. So let's take few more questions. Here one question is there. Let's trigonometry, prove that question is cotangent square of A into secant A minus 1 upon 1 plus sin A plus secant square of A into sin A minus 1 upon 1 plus secant A is equal to 0, right? So here we have to prove that this sum is equal to 0. Okay, so we can prove here one is sine and one is secant here. So by left hand side, what we can take? We can take the LCM. LCM here is 1 plus sine A into 1 plus secant A, right? So when we open the bracket, right? So we have 1 cotangent square A into secant A minus 1 into 1 plus secant A, right? 1 plus secant A, and same here, plus secant square A into sine of A minus 1 into, that is again 1 plus sine A, 1 plus sine of A. So we will apply the identity here, A plus B, A minus B, right? So here what we have denominator is same, 1 plus sine of A into 1 plus secant of A, right? And here we have cotangent square A, and here we have secant square A minus 1. Okay, and here we have secant square A into sine square A minus 1. Sine square A minus of 1. Right? So we know 1 minus the identity here, that secant square A minus 1 is equal to tangent square A, right? And same here, sine square of A minus 1 is equal to cosine square of A, right? Or sine square A minus 1, that is minus of, it is here minus sine square A. Okay, so here we can substitute the value, that is again 1 plus sine A, 1 plus secant A. So we have here the value cotangent square minus cotangent square A into tangent square A, and here secant square A into minus cosine square A. Okay, so reciprocal they will cancel. We have here 1 plus sine A into 1 minus secant A. So here we have 1 minus 1. So 1 minus 1, that is 0, right? So here, which is equal to your RHS, right? This is equal to your RHS. Okay, so this is the question here. So next one, one more question is from AP, a good question. Question is, if the 14th term is equal to 2 times the 8th term and the 6th term is minus 8, find the sum of first 20 terms, right? Question is, if I'm writing the statement only that A plus 13D means 14th term of AP is equal to 2 times its 8th term. 2 times its 8th term and sixth term is equal to minus 8. Sorry, it is 5. The sixth term is equal to minus 8. Find S20. Find the sum of 20 terms. Right? Do it fast. Again, I am repeating. The 14th term is equal to 2 times its 8th term, and here 6th term is equal to minus 8. Find the sum of first 20 terms. Right? So here what we have, when we open the bracket, we have twice of a plus 14b. Right? So a plus 13b. So when we subtract, so we have 2a minus a is equal to 13b minus 14b. Right? So here what we have, a is equal to minus of b. Right? A is equal to minus of d. Okay. So here what we have, a is equal to minus d. So here minus of d plus 5d is equal to minus 8. So plus 4d is equal to minus 8, or d is equal to minus 8 upon 4. That is minus of 2. So common difference here in this case is minus of 2 also. And what is the first term? A is 2. A is minus of d. So a here is equal to minus of minus 2. So a is equal to 2. Right? So here we want to find the sum of first 20 terms. S20 is equal to 20 into, so 20 by 2 into 2a. 2 into 2, 4 plus 19d is minus 20. Right? So here this is 10 here. 10 into 4 plus, it is minus 38. Right? So minus 38 means 34. So it is equal to into minus of 34. So answer is minus 340. Right? Sum of the terms, sum of first 20 terms, that is minus 340. Right? Sum is minus 340. So find the next question is find the HCF and find the HCF find the HCF of find the HCF of 96 and 404 by prime factorization method, and also find their LCM right? So here 96 prime factors, we can take 96, that is 4 8, again 2 4, again 12, again 2 6, 2 3, 31, right? So prime factorization of 96 is equal to 2 raised to power 1, 2, 3, 4, 5 into 3 raised to power 1, whereas 404 2 200 and here 2 101, right? So here 404 prime factorization is 2 raised to power 2 into 3 raised to power 0 into 1 raised to power 1. So here HCF, highest common factor, that is 2 raised to power 2, 3 raised to power 0 into 100, here is 101 raised to power, that is 0 here. So here 101 raised to power 0, which is equal to 4, right? The highest common factor is 2 raised to power 2. So HCF is, and what is the LCM? LCM, highest power, that is 2 raised to power 5, 3 raised to power 1 into 101, right? So we can multiply here 2 into 2 into 2 into 32 into 303, right? So 303 into 32, here 3 2s are 6, right? 6 and here 909, so answer is 6969. What is the LCM? LCM is 9696. Okay, so very right. HCF is 4. Okay, so this is all about today's class. So Sahil Preet, it is very right, 9696. Okay, so this is all about today's class, right? So work hard and stay safe and stay healthy.